So if you cannot hear me well, let me know because I'm in the auditorium. So I hope the sound is good. So the image, you can see me in the bottom of the image of the shared camera. So I hope you can see the shared screen also. Yeah. Okay. So I'm sharing the screen of my computer. I think it's okay. So I'm looking at the syllabus. I hope you are all well and that you already started working in the practical classes with Python. So as I mentioned in the previous class, the idea is that you develop a data visualization application. You have two options, okay? So some of you are more here into programming and learning how to program. So I recommend for those cases that you use Python, that you are learning with Professor Nuno or Mafalda, okay? But if you are not really into that, which is perfectly okay also, you can take the option of using Tableau, okay? So Tableau, you have two options. You can use Tableau Public if you want, okay? In the syllabus, in the Moodle, I have put there the link for Tableau Public, which is the free version, okay? If you believe in free things, it's not really free because everything you put there will be available to the public, okay? So don't publish their materials or data that you don't want others to see. But you, as a student, you also have access to the real Tableau, okay? So you can use the commercial version, okay? I've put here a link in week 2, okay? This is different from Tableau Public, okay? So this is a paid version. You don't need to pay because you are students here. You already paid, of course. So, and you have access to a free version of this software for 1 year, okay? So you can also explore this version if you want for the final project. So I would say that if you want to use Tableau, you can use either the public or the non-public version. It's up to you to decide. What it matters in the end is that you develop a data visualization application using data visualization principles, okay? And then you implement it and make it available online, okay? So that's the objective, don't forget about it. Okay, so for today's class, which I apologize again, I had to miss the last class due to an health issue, okay? And now I had to put this compensation class on Saturday. I know it's not so nice for you, for some of you at least. But I also put this session recording because of that. Some of you might not be available to be here, so you can consult online the recording of the session, okay? Okay, so yeah, for today, so if you go to the syllabus, let's take a look. So this is class number 2. So the dates here are not okay. I will correct this. So today we are going to take a look into data abstraction and data types, marks and channels, okay? So as I mentioned also, this corresponds to a book, okay, which you have access to using NetPA, the access online, what's the name of that? It's the VPN, sorry. The VPN, if you are outside NovaMS, you need to access it using the VPN. So it's the data visualization book. So the contents of today's class, you can read chapters 2, 3, and 5, okay? So please take a look at that. Also for the previous class, read, please, the chapter number 1. Today we are going to cover in a very summarized way these 3 chapters, okay? Then please take a look at the book because the book is much more developed than the things I'm going to talk here today, which I don't have time to cover in detail, okay? Also, I think it's the best way to study for the exam or the test. because the contents will be about the contents of the book. Okay. Okay, so I think we can start. Okay, so chapter 2 is about data abstraction and data types. Okay. So we'll be working with data. It's up to you actually for thinking about for the application you want to develop. I'm not sure if you already know what data set you are going to use. There are plenty of data sets available. Okay, so it's up to you to find one that fits your interests. So don't work with data sets that don't make sense for you. Okay. Don't forget also that the idea of the project is to tell a story. We'll be covering also data storytelling in the end. So the idea is not just to create 10 types of charts for a data set. Okay, so the idea is to develop a data visualization product that tells a story. Okay, so you want to communicate something. Okay, so it's very important to identify the objectives of your data visualization application. Okay, so we'll be working with data. Data corresponds to facts and statistics collected together for references or analysis. Okay, so it's up to you to find that data set. In the practical classes, you will be working with some data sets. Probably we have some data sets from job or from previous projects you have developed here. So it's up to you to start doing things that are compatible with your interests. Okay, don't do the exercise, don't do these projects just an exercise to go through the course, but try to, I don't know, for instance, working already towards your thesis, for instance. Okay, so try to work with data that matches your interests. Okay, so data, if you just provide numbers, it's not enough. Okay, so we need some kind of semantics to understand what is the real world meaning. Okay, so, and there are several types of data. Okay, so we'll see now what are those data types. Okay, so we have here an example. So this is some values. Okay, so without semantics, we cannot understand what is their meaning. Okay, this is also important. So when preparing your report, try to describe your data set. Okay, don't just assume with some that we'll understand what are the variables you are working on. So try to provide some semantics about the data you are going to explore. Okay, so sometimes I see tables in reports with some very strange field names. Okay, so try to put them in something meaningful. Okay, of course, I'm not expecting you to use many variables for this project. Okay, but sometimes it's not possible. If you have 200 variables, maybe you can put in an annex the meaning of the variables. Okay, but if it's just 4 or 5 or 6 variables, maybe you can use some meaningful names. Okay, so we understand what do they represent. Okay, so data types. So we have these data types we'll be working on. So items, this can be also attributes, links, positions, and grids. Let's see each one individually. So items, you already, if you work with tables and databases, this is nothing new for you. So an item is an individual, so it's a row in the table. Okay, that can also be a node in a network. Okay, so, and we can have attributes for our nodes. Okay, so attributes are properties, okay, that can be measured, observed, or logged. Okay, so this is a table. Okay, we have items, which are the rows. The variables are the attributes. Okay, variables are also called dependent variables. Okay, if you see this designation, don't take it as a strange designation. Okay, so then we can have nodes, as I mentioned, to define items. Okay, and then we can also use links which describe connections between items. Okay, and these links can also have attributes. Okay, so I have put here my personal research network, the persons with which I collaborate the most, and also my publications and contributions in terms of documents. Okay, so this is something that can be generated in the Elsevier system. Okay, if you have your profile there, you can see your publications, and you can create this kind of networks to see what is your network. This could be also be a social network, but for this case, it's a social network, but just for my individual research profile. Okay. Okay, we'll be working also with positions. Okay, don't forget we are here. So if you see the book, you will see exactly what I'm explaining here. This comes from the book. Okay, so we have items, attributes, we have links, and now let's see positions. Okay, positions. If you did already some tutorials in Tableau, you also be working with positions like countries, and then you can represent, for instance, attributes associated to those countries. Okay, so using positions is very interesting because we understand very, very well, and we communicate very well information about position. Okay, for instance, this map here, it's about smart and sustainable cities. It was an index created for Europe. Okay, and the authors used positions to identify the value of the ranking. Okay, so we have information which is provided spatially. Okay, you can do this in Tableau or in Plotly in the practical classes. I'm not sure if you already started working with spatial data in the practical classes. Not really. Okay, but it's possible, and I think you are going to cover that. Okay. Okay, yeah, so basically what you have some polygon shapefile or something like that. I don't know if you use shapefiles. No. Okay, so these are spatial data formats you can visualize in the applications you are working in the practical classes, or in Tableau also. You can upload shapefiles, and then the shapefiles are associated to tables. Okay. In this case, the table has the name of the country. Each line is one country, and then we have multiple attributes. It can be the name of the country, it can be the value of this rank score, and then we can represent the value of the rank score using some kind of symbology. Okay, in which you create classes for representing continuous values. Okay. So consider the possibility of using spatial data. I think it's very, very interesting. Okay. Then finally, we have the last data type, which is the grid. I'm going back here a little bit. Okay. So we have these 5 data types. I presented examples for every, but now let's see the last one, which are grids. Okay, grids. Okay, grids can be images, okay, in which we have cells or pixels. Okay, they can represent photographs, for instance, the photos you take with your smartphone in JPEG format or TIFF format, but they can also represent continuous surfaces like elevation. Okay, so whenever you see elevation maps, this means that every cell or every square of the image stores the value of the elevation, and typically these are obtained by interpolation or by other methods. Okay, so I don't know if you have worked with interpolation before. Okay, some of you in statistics maybe, or in geostatistics, or someone that has worked with GIS. So you can if you collect a sample of pollution points, for instance, for Lisbon, okay, let's say you want to create a map with the pollution for Lisbon. You are not going to measure every possible places in Lisbon because you don't have sensors to do that. So what we do, we have a sample of observations, okay? We record the pollution for a certain moment in time and we store that in our table. So we have points, geographical points with values for pollution, okay, that correspond to a location in Lisbon, let's say. And then we use an interpolation method, okay? Interpolation is estimating unknown values from known values, okay? So we know these values for the points we have collected, and then we are going to use a mathematical function to adjust the surface to the observed points, okay? So this is called interpolation. I'm estimating values, unknown values from known values, okay? So if you see this kind of data, you'll know what it is. Can be, for instance, any continuous phenomenon, like, for instance, noise pollution, which is very common here at Nova MS. We have the plane crossing our head every day. Can be pollution, air pollution, can be precipitation, can be elevation, etc. Okay. Okay. Then one thing we need to understand also, it's the difference between structured data and unstructured data. Okay. So typically we'll be working here with structured data. Okay. In which we'll be dealing with known data types and semantics. But some of you probably have been working also with unstructured data like text mining. Okay. You have heard about this concept before? I don't know. I'm not sure if you've been working with this. Oh, next trimester. Okay, so there will be a course about text mining. So basically, it's non-structured or unstructured data. Okay, so we need to use some kind of techniques to make it available into tables that we can work with. Okay, so I'm not going to cover this here, but it's important to understand the differences between this type of data. Okay. Okay, so we have tables now for the data set types. Okay, so we've seen data types before. Now we have the data set types. Data set types can be any of these four. Okay, so tables, networks, fields, or geometries. Okay, so let's see examples for each one of these. Okay, so tables, I think most of you already worked with tables before. This is nothing new for you. As I mentioned before, tables are composed by items and attributes. Okay, then we can use also multidimensional tables in which we have multiple keys. Those of you who have worked with databases before, probably have worked with multidimensional tables. Okay, but don't forget, for this course, just get a simple table. Don't complicate the data collection, because you are not going to be getting points because of that. So the idea is to tell a story with data. Okay, so let's try to focus on that objective. Okay. Okay, these are some examples of multidimensional tables. And then, yeah, visualizing tables, that's why we have this course. So there are multiple options here. Okay, so, and that's the objective of this course also, is also to explore some of the possibilities you can follow to present your data the most effective way possible. Okay, so we have here examples which I'm going to cover later on. Okay, it's like these parallel charts in which we have multiple attributes. So this is a link which you can consult. Okay, so this is interesting because this is an interactive application in which you can see multiple attributes at the same time. Each line represents an item. Okay, and then this is about cars. Okay, and then you can do selections over this axis, okay? And then you'll get the results with a different color according to the selection you provide in the multiple attributes, okay? So this is very effective because you are providing a lot of data here in a single visualization product, okay? So yeah, this is another example of a type of chart which also groups a lot of data. This is about publications about this field of optogenetics, okay? So we are representing several years, okay? And then these are names of journals, okay? And they are grouped using colors. I don't know exactly what the colors mean in this case, but we have blues, we have reds, we have greens, so probably these are of the same field, I guess. And then we have points, okay, with different sizes that represent the number of publications by each journal about optogenetics throughout the several years, okay? So this is also a very interesting way of showing a lot of data altogether in a single chart, okay? So this is a very good one. So it shows clearly that there has been an increase in the number of publications in optogenetics, okay? And then we can see which are the journals that publish more in this particular field, okay? So we learn a lot by seeing other examples, okay? So, and also this is one of the objectives of this course, is to expose you to this kind of examples so you can get inspiration to go beyond the simple bar chart, okay? So not saying that the bar chart is not good, that's the most effective one actually, but if you want to provide something with a different perspective and looks, I think it's very important that we see other kinds of implementations, okay? Okay, graphs and networks. These are sets of vertices, which are nodes, and edges, so the links between the nodes, okay? I already mentioned this before. So we can visualize graphs using the node link diagram, okay? We can create also interactive applications in which we change the perspective of the nodes, okay? And they actually can also drag and drop or change the disposition of the nodes, okay? But these are all the same data set here, okay? Or the equivalent. Actually, this is not the same data set. But we can either see this using the node link diagram, or you can, if you prefer, using a 2D representation, you can use a matrix, okay? So this is an interesting matrix that shows the characters of a book, okay? So, and their interaction in the story of the book, okay? So we have the names of the characters on the top, and then they are repeated on the lines, okay? And then we have a matrix denoting the interaction between the characters, okay? Or we can also see tree maps, okay? So I don't know, probably you have seen this type of chart before, okay? This is called tree map, okay? So you can do this very easily in Tableau, and I think you are also going to learn how to do this in the practical classes with Professor Nuno and Mafalda, okay? Okay, nodes can have attributes, links can have attributes, okay? When you're talking about trees, it's because there is a hierarchical structure, okay? If it's just a network, it doesn't mean that it has a hierarchical structure, okay? So we have, for instance, social networks. Nodes can be characterized by gender, age, income, etc. Okay? And links can be, for instance, characterized by the number of interactions between the nodes. Okay? Yeah, we have here another examples. I put here some links. Hopefully they are still all working, but please consult the links so you can have access to some very, very crazy examples sometimes but they can be inspiring for you to do your final project, okay? So here in this link, I hope it works, visual complexity, you can see a large number of examples of network visualizations, okay? Yeah, fields. So let's go back here. So I'm following the structure of the book, okay? So we have talked about tables, networks, and now let's see fields. So fields are composed of grids that depict positions, and they can also have attributes, okay? And then we have geometries. Let's see the fields. Okay, fields, it's when we are using grids, okay? I already explained what the grid was before, okay? Sometimes if you are working with a special data file representing countries, typically that's a geometry, okay? But if you want to overlay, for instance, a data set that represents noise pollution over the Lisbon area, for instance, you'll be using fields, okay, which are grids, okay, like these ones. I already explained the interpolation process, okay, but it could be a satellite image, okay, so which corresponds to an image, okay, it could be a photograph, okay, so it could be a photo taken from an airplane, okay, you could overlay this spatially over Lisbon, okay. Continuous fields, you can also get free data sets about continuous fields. For instance, if you are interested in climate data, you have the WorldClim website. Okay. From here, you can download for free huge data sets that cover the world about climate. Okay. So I use these very often for some of my research studies. If, for instance, if you are interested in getting a map with temperature of Portugal, average temperature of Portugal, you can come here and extract the part of Portugal, and you will have a map with a grid in which each cell represents the value of the average temperature in that location. Okay. What is important when working with continuous fields is also to be aware of the spatial resolution, okay? Because when we are working with maps, so the size of the cell or the size of the pixel is very important, okay? When you have a smartphone, probably if you are very interested in taking photos, and when you are buying a smartphone, maybe you will look into the quality of the camera, right? So you have the resolution there, or the number of cells or number of pixels that each photo takes when you use the camera, okay? So if you have more pixels, it means for the same geographical area, it means that these pixels are smaller, okay? So they have more spatial resolution. So it's more detailed, so they are more heavy in size, okay? So be careful. Sometimes we want the biggest spatial resolution, but that will have a price, which is the size of the data, okay? So be careful. So then you need a big disk to store this kind of data, okay? So this is very generalized data sets. When we are working with climate doesn't change every 10 meters, so we don't need cells of 10 meters. These cells are, I think, 1 kilometer or so, okay, which is good for climate data, okay? Yeah, we can also have more different types of scale, okay, when using grids. This is an example of representation of skeletons, okay, so we can also use images to do this representation. We can represent wind phenomenon, okay, so these are examples of fields. I have a very crazy example here, which is a PhD student from Nova MS. He developed this project and he used the database of the human body, okay? So there is a database of a human body, which is available upon request. But basically, it's a set of images that represent the human body. And well, if you are too sensitive, I will not describe this. Please turn off the sound, but it's a human body that was frozen and cut in slices, and each slices is a photo, okay? And what the student did, then he reconstructed the structures of the body using an application he developed, okay? And he associated the human body to a database, okay, which is very interesting. Okay, so, but this is a very strange data set, okay? But it's a very interesting one also, and then you can use computers to reconstruct these structures in 3D. And yeah, take a look at this paper if you want to know about more details. Okay. Yeah, then we have also more complicated types of fields, can be volumes. Okay, not so much common to see in use, but they exist. Or using, instead of squares, using different types of structures like triangles. Okay, if you work in GIS, Geographical Information Systems, you know what is a triangular irregular network. You can use this kind of structures also to represent continuous phenomenon like elevation, okay, or pollution or whatever, okay. So continuous data is very interesting, but it requires a lot of space in the computer. It can delay the visualization if it's online, because these are not simple data sets in the sense that they are heavy, okay. So you need to have some strategies to make this data available quickly to be consulted, okay. Okay, finally, geometries, okay. As I already mentioned, we can have positions. Positions can depict lines in real world, corresponding, for instance, to streets or rivers. Can be also be depicted using points, for instance, locations of buildings or locations of users with smartphones moving on the space, okay. Can be locations of automobiles, or of cars, for instance, sorry. So one can represent also a city, depends on the scale we are working on, okay. And we can also have polygon data, okay. So we have lines, points, and polygons, okay. What is interesting here when using geometry is that we can overlay these layers together and have an integrated data view, like in the GIS. So basically, we can see all the layers together if they are referring to the same spatial location, and then we can query individually each one of them, okay. So, but this is more for people who are working in GIS. This is very common, but I think for your data visualization products, probably you will have polygons of countries. Maybe you'll have some points for representing some indicators. Maybe you will have some polygons that can be the countries, as I mentioned, and then you can use colors to represent the values, for instance, of some kind of attribute like crime data, okay, crime level or administrative area, for instance, okay. Yeah, this is an example of geometries. You have seen maps before, I'm sure. So whenever we are looking to these kind of maps, these are also called choropleth maps, okay. Basically, we are associating polygons to quantitative attributes, and then we are coloring those polygons according to classes, okay. So for instance, election results, okay. For instance, level of education per unit, okay. So you can check the census data in Portugal or wherever. If you go to the INE website, which is the census authority in Portugal, they make available a data set of polygons, okay? And they also make available the data from the several sensors, okay? More than 100 variables for each sensor. So I can create different maps for the sensors data in Portugal. This is very important. If you go to a website called Core Data, okay, you will see many maps like this, okay? So you are here also to learn how to create these maps. If you do the tutorials in Tableau, which I put in the link in the Moodle, you will see how also to create this kind of maps using shapefiles and attribute quantitative data, okay? This is very good to communicate phenomena that vary spatially, okay? If you just put a chart with the value of, this is educational attainment. If I try to put this in a bar chart or a pie chart or points or whatever, it's not so effective as using a map to do this representation, okay? I don't know if any of you already work with this kind of data, spatial data, and if you know how to create this kind of maps. I think it's very useful because sometimes we need to show data per county or per freguesia or per municipality or per country, and we need to know how to create this kind of representations, okay? But this also brings me to a problem or to a way of manipulating the visualization, okay, which is the number of classes, okay? We need to see which is the best number of classes, and we also need to be careful on the way we create the classes, okay? The classes can be created by multiple ways. You can create equal classes, equal intervals, and this will turn into a completely different map, okay? But if you create natural breaks, this will be another map, okay? So it's up to the visualization designer to see which is the best option to communicate whatever he or she wants to communicate, okay? So that's why it's important to describe in the methodology. If you are going to use this kind of choropleth mapping, okay, to explain clearly how did you create the classes, okay? If you don't explain clearly, it means that maybe you are trying to manipulate the audience, okay? You can do that. Not very ethical, but there are ways to control the way the map appears legally correct, okay? Actually, there is a very interesting book called How to Lie with Maps, okay? So we can take options to control the way data looks like in the data visualization product, okay? But we should do that in a responsible and informed way, not to manipulate opinions. And of course, that might happen, but you are here also to be ready to understand when you are being or subject to this kind of visualizations to show some kind of phenomenon that is some kind of manipulation involved, okay? So we should identify the methodology to create the classes so we are clear about what we do, okay? Okay, so another type of data set types are cluster sets and lists. So we can also represent these groups of items using sets or using lists. So not so effective if the list is very big. Or we can also represent clusters based on attribute similarities, okay? So maybe you are also interested in using some kind of data visualization like this, but it's not so common in this case. Okay, here we have an interesting example. Sorry, my microphone. So very interesting data visualization product from Elsevier. So this is about journal term co-occurrence cluster similarity map for 6 nursing journals. Okay, so color is encoding the journal name. So probably in the methodology we have the names of the journals. They are not here, but if you check this link, hopefully it's still working. color should always mean something. I already mentioned. Okay, so use color to provide information, not just because it's beautiful, but to communicate some kind of information effectively. So this should be probably the name of the journal. So then we have points with different sizes. Okay, they should reflect the number of times a word appears. Okay, so the bigger it is, the more common it is, the use of that word. And this is three-dimensional. It's interactive. Okay, you can drag and drop the perspective, because whenever you are using 3D, it's very important to provide interactivity, because you can be hiding structures that depend very much on the perspective you are using. Okay, so, and of course there is this occlusion effect also. Probably there are some circles that are behind other circles and we cannot see them. Okay, so this could be, for instance, an example for you to implement in your final project. Okay, why not? Okay, data sets. Probably we'll be working with static data sets. That's the most common type of data. You have a static table, but you can also work with dynamic or that are constantly updated data sets if you know how to do that. Okay. For instance, one example of dynamic data sets are, for instance, the data you can see in Google Maps about traffic. Okay, so they are constantly being updated. So whenever you calculate a road trip from point A to point B, the calculation is made taking into account dynamic data. Okay, that is used to calculate the traffic congestion. Okay, so, and then the results of that calculation take also into account the traffic congestion. Okay, probably all of you have used this feature, or most of you. It's very, very good. Okay. Yeah, then we get to attribute types. I need to speed up a little bit. We have still half an hour. These are very short classes. Yeah, we have categories and then we have orders. Okay, categories are very important. Can be sizes, can be shapes or colors. And then we have quantitative data. Okay, so we'll be working either with categories or quantitative data most of the time. Okay, so data can also be ordered, can be sequential, it can be diverging, or can be cyclic. Let's see some examples for this. Okay, so there is this interesting paper, kind of old, but still where it is described the types of data: nominal, ordinal, interval, ratio. So take a look at it. The paper is available in this link. And yeah, I think you can also learn a little bit from this. Okay. Okay, sequential data we have here an example, for instance, age, height, weight. Diverging, sometimes you see this kind of maps, for instance, elevation. If it's in the sea, you have negative values. If it's above the sea, you will have positive values. Okay. Cyclic data can be, for instance, hour, week, years, and other examples. Okay, so to summarize, so this is the figure from the book. Okay, we have seen data types, data set types. So we have these examples for everything that is in this summary image. Okay, so it's up to us to see which is the best way to transform data. Okay, in such a way that it will correspond to what we want to communicate the best possible way. So this is not automatic. It's a decision we need to take. Okay. So then I have here some examples. So explaining what is an item, also called as an independent variable. What are attributes, also called dimensions, dependent variables. Okay. Semantics. Typically, it's the name of the attributes, but sometimes, for instance, if you go to the INE data site and you download the census data, you have hundreds of variables, okay? So then they have links for the names of the variables explaining what do they mean, okay? This is very important because there are so many variables, you cannot find the meaningful name for each attribute name, okay? So sometimes you really need to make a dictionary or where you explain what each variable means, okay? Keys. Okay, in this case, I'm expecting you to work with a simple table with just one key. So the keys can be an identifier, okay? Okay, here by looking at this table, we can also try to figure out what attribute types we are working with, okay? So we have categorical, ordinal, and quantitative, okay? And let me know if you don't understand this. And that's all. Okay, so I think we can go to the next chapter, which is about marks and channels, okay? Okay, marks and channels. So you have a chapter corresponding to this. So basically it's where we are now going to decide, okay, we have this table, what marks and channels are we going to use to create our data visualization product, okay? So, and there are multiple options for doing that, okay? So there is this in curiosity here. I don't know if you ever think about this, but let's say you have two numbers. How many different ways can you visually represent these two numbers? Okay, this is an example taken from this site. And this person here, this author, he created a 45 ways of representing these two numbers. Let's see some of them. Okay, I'm just going to open it. Let's see if this is working. I think I have the example later on. Let me see. No, it's not here. Yeah, I don't have here the link. Let me see. I have to. Yeah, nice. Okay, yeah, this is. If you then consult the link, you will see this PDF. So we come up with 45 different ways. You can see if you understand all of them. I'm not going to go through all of them, but there are many, many different ways of doing it, okay? So this is what we are here for. We have to take the decision on how to represent the quantities or the categories that are in our table, okay? So we tell the story the most effective way, okay? So marks are geometric elements that depict items, okay, or links, okay? We already know what are items or links. Visual channels are the way we control the appearance of the marks, okay? And our objective here is to try to select the most effective channels, and we are going to see how can we take this decision, okay? So for our data, for our marks in this case. So let's see what kind of marks we have. So as I mentioned before also, we can not, for the geometries, you can have points, lines, or areas, but it's also the same thing for marks, okay? We can use points to represent items, okay? A point can be, for instance, a person. So we have different persons that have different attributes, okay? Or it can be countries, or can be cars, or can be whatever, okay? Then we have lines and areas, okay? So let's see examples for these. So we can also use marks as links. This can show containment and connection. Let's see examples, okay? Okay, then we have visual channels. So visual channels, it's the way we are going to control the appearance of the marks. And these are the characteristics that we can work with. So we can work with position, we can use different colors, we can use these different shapes, we can use tilt, so different angles, okay? We can use size, we can use area, and you can use volume. Okay, so let's see some examples here. Okay, so this is also important for you to incorporate this language into the final report. Okay, so let's use data visualization language. So let's just call this a simple bar chart. Let's try to describe them using marks and channels. Okay, so bar charts, they encode two attributes using a line mark. Okay, so when you're using bar charts, you're using lines. So if you go back a little bit, you have lines here. Okay, so it's one way of using marks. Okay, a bar chart uses lines. Okay. So, and what do bar charts encode? Okay, they encode. So they use the vertical spatial position. Okay, for the quantitative attribute. Let's say each bar chart represents an individual, a person. Okay, and let's say this is the average grades of that person, of those persons. Okay, so bars encodes a quantitative attribute using line marks. So the quantitative attribute is the grades of the average grades of each person. Okay, so they also use the horizontal spatial position to encode a categorical attribute. Categorical attribute because you have different people, each one represents a bar. Okay, so we have quantitative and qualitative attributes. We have the horizontal spatial position and the vertical spatial position. Okay, so let's try to read these kind of representations when explaining the charts you are using in your application. Okay, we are using a bar charts to encode these attributes horizontally or vertically, and also this another qualitative attribute that represents, for instance, the students of a class. Okay. Okay, so these are the bar charts. I'm sure that all of you have worked with bar charts before, but probably you never use this kind of description to define what's there in the chart. Okay. For instance, scatter plots. Scatter plots, I'm sure all of you have worked with that also. So plots encodes two quantitative attributes. So before we have one quantitative and another qualitative. Here we have two quantitative attributes. Okay, and we are using vertical and horizontal spatial position. We are using point marks to represent those items. These items can be, for instance, countries with GDP and debt, level of debt or level of unemployment. Okay, so we are representing two quantitative attributes. Okay, we can add more attributes to the representation. Okay, we can add color to the scatter plot to encode another attribute. Okay, that's what we did. We use color to represent something, as I mentioned before. So don't make just tutti frutti charts with all different types of colors. They don't mean anything. Okay, so let's say you are using another attribute, can be region of Portugal. So all the points from the same region will have the same color. Okay, and we can also add another quantitative attribute on the top of that. For instance, using the size to encode a fourth quantitative attribute. Okay, so the scatter plot can have 2, 3, or 4 quantitative attributes. Okay, so we are using, in this case, line marks for the bar chart and then point marks for the scatter plot. Okay, so try to understand this description. This is a good way of using that also in your final project. Okay, so channels, we should select the channels that are more expressive, okay, and more effective, okay? And there is a ranking of channels created by researchers that work in this area based upon lots of experiments that were made with humans, okay, but not dangerous experiments. So doing experiments with users to perform certain tasks in interpreting some charts, quantitatively measuring the effectiveness of those interpretations. We have not me, but researchers in these areas have come up with a list to the most effective channels, okay? Of course, this will depend on using quantitative or categorical attributes on the right, quantitative on the left, okay? So we should always give priority to the top channels, okay? And the most effective channel to represent quantitative attributes is position, okay? I already mentioned position in bar charts and scatter plots, horizontal spatial position and vertical spatial position. This is the most effective channel for quantitative data, okay? Then if we go down the line, we have length, we have tilt, we have area, depth, color, luminance, color saturation, and volume, okay? I'm going to provide you some examples in which we are going to use different types of channels, okay? But it's very important to understand that we should always give priority to the top because research has proven that these are the most effective, okay? So, okay, if you are using categorical attributes, we'll give priority to spatial regions, for instance, using maps for showing indicators that are different from country to country or whatever. Color is also very effective. Then we have others that are not so effective. So now I'm going to give you some examples of these principles, okay? So we have expressiveness principle and effectiveness principle, okay? So the idea is to show with the expressiveness principle all the information. Oh. Temos aqui aniversário. Ok. Ok, parabéns neste caso. Okay, so we have effectiveness and expressiveness. So effectiveness principle, so it should be noticeable. What we are going to show should be things that are easy to understand and read, okay? So let's see other attributes of effectiveness. So it should be accurate, it should be possible to discriminate, it should be possible to separate, maybe to pop out, maybe also to do some kind of grouping, okay? So let's see examples. So for the accuracy, so there are experiments with humans, I already mentioned. So we have this example taken from the book saying, so this is to explain you how we should decide the channel. So there were these experiments made by researchers, and they have done experiments to figure out, for instance, that people are very good at estimating lengths, for instance, okay? So that's why bar chart is very good to be used, because we can easily compare the size of the bars if they are aligned, okay? So we are good at seeing the differences between 2 or 3 different bars, okay? We are not so good at estimating areas, okay? So for instance, if area is 1, okay, we tend to underestimate the value of the area. And the same goes for the depth, and the same goes for the brightness. So that's why that scale comes there using this kind of information, okay? For instance, for saturation, we tend to overestimate saturation of colors, okay? So if you are using to represent a geographical map, different colors, different saturations of the same color, we tend to overestimate the value by 70%, which is a lot, okay? We also tend to overestimate electric shocks, okay? So you understand better the meaning of the other experiments, okay? If you take an electric shock, hopefully not, we tend to exaggerate the value of that perceived sensation, okay? Of course, this is related to psychology, okay? So yeah, this is another experiment which is described in the book to show that positions are most accurate. So then this was made with users, experiments with users, and these are the results. So on the top are the best results. So we have bars on the top, then angles, we are not so good. Circular areas, we are not so good either. And also rectangular areas like the tree map I've showed you before, we are not so good comparing the values of the areas of the rectangles, okay? So yeah, I know we have all these possibilities available when we are working with software, okay? We can select, okay, I'm going to use bar charts or tree maps or, okay, but try to justify, okay, we are using this kind of visualization product because it's the most effective. And actually you can refer to this author because, yeah, he found out that these are the most effective types of chart when we are talking about accuracy, okay? So bar charts are very good, okay? It's the best we can use for representing our quantitative data, okay? If you use angles, it's not so good because visually it's very difficult to us to distinguish between very similar pie slices of the pie chart, okay? So, and so this is the result of lots of experiments, okay? Yeah, we can use unframed or unaligned bar charts. Here we have more difficulties to compare the sizes, okay? If you use a frame and an aligned chart, it's much better for us to understand the values, okay? We can use distractors like pre-attentive features. If you use aligned bars, it's much better for us to understand the data, okay? Sometimes we see on the television things like this. I see many times, sometimes we have politicians or that go to debates with charts on their hands and they show the charts. Sometimes the chart doesn't start in 0, okay? And then they are not proportional, okay? So sometimes you can see much bigger representations for one value than for the other, but it's not okay because the scale is not good, okay? So you need to use the representation proportional to the data, okay? Then we have here, just to conclude with some examples, some exercises you can try to do on your own, okay, to see if you are good estimating lengths, sorry. So we can maybe easily understand that B is 2 times bigger than A. We can do this kind of experiments. Actually, I should have here, I don't know why it's not appearing here, the correct answer, but for some reason it's not here. For instance, for estimating the angles, we are not so good. We have lots of difficulties to say how much times the angle of A is bigger than comparing to B, okay? Comparing circles, we are not also so good either, okay? And there is a very interesting application, which is the eyeballing game, okay? Where you can test your own capabilities to understand if you can do a good estimate about sizes, angles, circle sizes, etc. Okay, so there is some exercises here, and you are asked to provide an answer, and then it provides the correct answer. Okay, so this is interesting to see how good are we in estimating, so eyeballing the sizes and angles and so forth. Okay, so strategies for increasing discriminability can, for instance, using different sizes of the links, okay, to represent, for instance, exports between countries, okay. Yeah, if you use colors like this, we cannot discriminate anything, okay. They don't represent categories, okay. It's not good. It's a bad example. This is a very good use of color. We have lots of lines, okay, but then we focus on a particular line with a pre-attentive feature, so the user immediately focuses on the story that the data visualization product wants to tell. Okay, this is about the person, which is described in this line. Okay, this is a terrible example. I'm also showing what you should not do. We also learn with that. So don't use maps with tutti frutti colors that don't represent anything. Okay, you cannot understand visually what's their meaning. Okay, so maybe key color saturation will be more interesting. Okay, instead of using categorical colors. Okay, this is a very well-known bad example also. This is a map showing 3 attributes at the time, okay, by color mixture, okay. So red would represent one attribute, yellow another one. One is red is for reading, red or kind of purple or fuchsia. Yellow should be writing, sorry, and blue earning money. So this is trying to represent these 3 attributes by mixing quantities of each attribute. Okay, so nobody can read this. Okay, it's very difficult to understand what's here. Okay, and it's a very difficult map to create. Okay? Sometimes the effort doesn't pay off. Okay, yeah, separability. So we have here examples. So fully separable when you use position and color. Okay, if you start using different sizes, separability becomes less noticeable. Okay, if you start using also width, if you start complicating this, then at a certain moment you cannot distinguish anything in your data. Okay, yeah, pre-attentive features, I already mentioned this. This is a very good strategy to direct the attention of the users to exactly where you want them to start looking at. Okay, there is a paper about this. There are many papers about the best ways of using visualization idioms for getting the most effective data visualization products. Okay, yeah, there are other examples: grouping, okay, proximity, similarity. Okay. Yeah, we are not so good using non-aligned or unaligned bars, because it makes more difficult the task of comparing the sizes. Okay, this already mentioned before. Then you can leave. This is an example taken from the book. You can take a look at it also. Yeah, and then we should, whenever you look at a data visualization chart, we should always try to figure out what marks are being used and what visual channels are being used also. Okay, so we already did this example. We are using lines in the first case. We are representing one quantitative and one categorical attributes. The second case, we are using points. The channel, its position, okay. In the first case, it's length, okay, and position, spatial position, horizontal and vertical. For the point, for the scatter plot, is also position, okay. And we have two quantitative attributes, okay. In the third case, we are adding color, and we have another categorical attribute. And we are using also size to add an extra quantitative attribute, okay. So try to read the visualization using this kind of data visualization language. Okay, we have here other examples. So the items we are representing here are sales. We are using different attributes. So visual mark, it's a point. I put here dot, but it should be point. Visual channel, position and color. Encoding rules. So we are representing sales using the points. We are using XY positions for price and profit, and we are using color for product type. Okay. Try to describe your data visualization products using this kind of language. Okay, so these are co-occurrence of characters in a book, Les Miserables, from Victor Hugo, and we are representing co-occurrences of the characters to see when do they interact with each other. Okay, so we are representing attributes, names, clusters, and frequency. So frequency, it's the color intensity. Okay, the darker, the most frequent are their interaction. The color represents clusters, and the position represents the names. Okay, the interaction. Okay, then you have here some exercises for you to practice. Okay, I should try to finish soon. So we have here some examples. Now you should take a look and see, okay, what are the marks, what are the channels. So that's an exercise for you to practice. Okay, here we are using marks, dots, points as marks, right? We are using as channels the spatial, horizontal, and vertical position. We are also using color for a categorical attribute. In this case, it's the type of metal, if it's gold, bronze, or silver, right? So this is an exercise that is useful for start applying these data visualization concepts. This is a very important, a very famous data visualization product, the Gapminder. I will let you try to figure out what it represents. So what marks are we using here? Points, lines, or areas? Which one do you think? Points, they're using points. Points represent countries, okay? The items we are representing are countries. Then we are using also spatial, horizontal, and vertical position. So vertical position represents children dying before 5 years per 1,000 births, okay, using a logarithmic scale. And the horizontal position represents the gross national income per capita, okay? So, and then we have also color for encoding a qualitative attribute, which is the region, okay? And then we are using the size of the points to decode or to encode the population in millions. So we have China, the biggest circle, and India, okay? The color represents the region. And then they are positioning according to the child mortality and also the gross national income. So bottom left, it's the the poorest and the countries that have the highest rate of mortality, and but the top right is the opposite. Okay, so it's a very interesting map because it's also inverted the y-axis. Okay, so the highest values are on the bottom instead of usually using the top. Okay, and also the disposition is very interesting because if you are in a Western country, we read from left to right, so it's also good to have this ascending order, and also the disposition of the map, like putting the chart, putting the title on the left, the legend on the bottom right. So all the blank spaces of the available space are filled with information. Okay, so this is a very good example of an important chart, and it's a very well reduced one. Okay. Yeah, an example of a map. Okay, this is geometry. Okay, we are using areas. Okay, areas depict US counties, right? And this represents a phenomenon which is the government payments to individuals in benefit programs, from food stamps to Medicare. Okay, so these are so the color goes from light. I think this is kind of orange or brown, I don't know, to dark color, dark red or something like that. So denotes some kind of intensity. Okay, so the darker areas are the most problematic areas for this indicator. Okay, this is a choropleth map. This is a very good way of representing this kind of phenomenon because spatially you get an immediate perception of where the problems are. If you use a bar chart to do this, as you could, or a scatter plot, you will not get the same kind of information or communication. Okay. Yeah, then you have other examples you can explore. Okay, and yeah, that's about what I had to tell you for today. Okay, so I don't know if you have any questions. So what I really recommend is that you try to make try to read the chapters corresponding to this presentation, so you understand and consolidate what I've told you here, and also try to make a parallel between this and the kind of application you are going to develop. Okay, because when writing the report, I would like to see that you are using data visualization concepts to describe your data set, to describe the results you got or the charts you are using, what are you encoding, what visual channels you are using, what marks you are using. So try to include these elements in the description of your product. Okay. Okay, so I will put this recording available in the Moodle. Okay, probably today or soon. And if you have any question, then let me know. Okay, just to remind you, next class will not be Monday or Tuesday again. I already sent an email explaining the situation, but it will be next Saturday at the same hour. Okay, so in the meantime, I hope you can start working in your final projects, okay, as soon as possible with your own data set, okay, because you need to understand that the deadlines are shorter for the trimestral courses, okay. You have to present your report or your application 10 to 14 April, and you have until 9 of April to upload the reports, okay, in Moodle. So about 1 month from now, okay, not so much time. Okay, so thank you, and see you next week. And let me know if you have any questions. Okay, I'll be around. Okay, I'm going to stop the recording. Just a moment. So